Let's understand the world a little better. I'm here with Harvard professor Avi Loeb, and I want to dive right into the topic. You might have found an alien object in the Pacific. What makes you think that it stems from aliens?
Well, not necessarily from technological civilization. We don't know that, but we know that this object came from outside the solar system. And it's the first time that scientists analyze materials from a big object, bigger than half a meter, that came from outside the solar system. So, in that sense, it's historic. And the reason we know that is because the US government satellites spotted the fireball from this object when it collided with Earth and burned up in the atmosphere. And it was moving faster than necessary to escape from the solar system. So, based on its high speed, we concluded that it came from interstellar space, and then the US Space Command confirmed that in an official letter to NASA that was issued 3 years later. And so after that, I decided to go to the Pacific Ocean to search for the materials of this object because it was moving faster than 95% of the stars near the sun relative to the local frame of the Milky Way galaxy. And moreover, it exploded only when the stress exerted on it by the atmosphere was far greater than other meteors that were cataloged by NASA, 272 of them. So that raised the possibility that it may be a Voyager like meteor. Imagine our own spacecraft, Voyager, leaving the solar system and colliding with another planet far away that looks like the Earth. It would appear as a meteor of unusual material strength and unusual speed. And to check the nature of this object, the first interstellar meteor, I led an expedition to the Pacific Ocean. We got funded at $1.5 million. We built a sled with magnets on it that we dragged on the ocean floor. The ocean was about 2 kilometers deep at the location of the meteor. And we surveyed a region which was 10 kilometers in size. And amazingly, we found an enhancement, an excess in the number of molten droplets from the surface of this object in the vicinity of the meteor path compared to faraway regions. And when we analyzed the molten droplets, we found that those along the meteor path have a very unusual composition that was never reported in the scientific literature for solar system meteors. This one had the abundance of some elements like beryllium, lanthanum, uranium, that is hundreds of times larger than the standard solar system composition. And that implied, completely independently of the speed of the object, that it came from outside the solar system, because you don't find this abundance pattern in rocks on Earth, the Moon, Mars, or asteroids. So we have two lines of evidence that it came from outside the solar system, one based on the speed of the meteor, and second, based on the material that we found at the bottom of the Pacific Ocean, just under the meteor explosion site, which had composition different than any solar system object that we know about.
And why would it specifically be from a civilization then? If it came
Oh,
from outer
oh,
space?
we don't know.
I,
So the suspicion was triggered by the fact that it had material strength larger than the rocks in the solar system, and that it was moving very fast. That was the reason. But in order to tell if it's artificial or natural in origin, what we need is a bigger piece of the object. And that's
hmm.
what we are planning to do in the next expedition, to search for bigger pieces. Now we know where to look because those molten droplets, roughly the size of a grain of sand, they tell us where the particles can be found. And it's sort of like rose petals that lead you to your lover. Those bigger pieces are really what we are after. And if we find them, we can easily tell the difference between a rock and the technological gadget, because the gadget may have a button on it. And then the question would be whether we should press a button, which is a separate question.
I think the object came to be found in 2014. Is that correct? That's when it.
Yes, it was spotted by US government satellites in 2014, January 8th, um, based on the fireball that it generated as a result of its friction in
And
air.
why has nobody since then, except from you, examined the object?
Yeah, that's an excellent question. So first, the reason I identified the object was I was interviewed on the radio at the beginning of January 2019. So 5 years later, after this meteor was discovered, and I was interviewed about another meteor over Kamchatka that was recognized in the towards the end of December 2018. And so, in trying to figure out what's known about meteors, I looked online and I found this catalog of NASA with the velocity measurements of 273 meteors. And as a result, I decided together with my student, Amir Siraj, to check the velocity measurements and see if the fastest moving objects could be from outside the solar system. So the 5 year delay was just because I was not aware of this catalog when this meteor was found. And then in 2019, 5 years later, I realized that it exists and asked the question, is it from outside the solar system? Very often it's the not asking the question. The people who
Hmm.
work in this area were not, they are thinking always in terms of solar system objects. And then it took 3 years for the US government to look back at the data and confirm at the 99.999% that it is interstellar. There was a letter issued by the US Space Command to NASA saying that in March 2022, at which point I felt confident enough to organize the expedition. And so that's the sequence of events that led to this discovery. And of course, the US government, for example, could have gone to that place before we did, but gladly, we went there first and wrote a scientific paper with the results of our expedition. We found the 700 molten droplets, and about 10% of the ones that we studied 57 of them and found five of them to be of this unusual composition. And the rest belong to the background that we find everywhere. Those five are found only near the meteor path. And so now we are planning to study all the rest of those spherules, molten droplets, and firm up the statistical conclusions of the paper.
Now, you said the object had higher concentration of different materials, if I understood it correctly, of different chemicals, or
Yeah,
what does
elements.
that? What can we conclude from that? From to its origin, what its origin is
Yeah.
like.
So in the paper, we talk about a possible natural origin. For example, if you have a planet not in the solar system but around another star, that is a magma ocean. Basically, the rocks on the planet are molten, and it has an iron core. Then some elements have affinity to iron, so they are attracted to the core and they settle. And the elements that are left behind and stay in the crust of the planet are of the type that we find enhanced. So
Hmm.
that could be, this is called the process of differentiation, and it could be responsible for what we find, except that we know that the Earth started as a magma ocean because it was bombarded by very heavy objects. One of the collisions with Earth generated the moon, and the moon was also a magma ocean to start with. And then Mars was the same. But the abundances we find in the crust of the Earth, the moon, or Mars do not match what we have in those special spherules that we found. So it must be a magma ocean planet around another star. So that's one natural origin. And of course, there is a challenge to that origin because you need the 10 to the power 23 rocks like that generated per star in the Milky Way galaxy in
Okay.
order to have a large enough population such that one of them will collide with Earth every decade. And that's a very large number, 10 to the power 23 per star, times the mass of this rock that was the meteor, which was 500 kilograms for half a meter object. um, that gives you the mass of the Earth. So what you need is roughly an Earth mass planet to be completely destroyed and into pieces of 500 kilograms each, 10 to the power of 23 of them, a huge number. And I'm currently checking if that is possible. Maybe it's possible, but I need to make sure that it works out. And then, of course, the second possibility is that maybe these special elements were selected by a technological benefit. For example, we know that uranium is used as fuel for fission reactors. And we
Hmm.
know that lanthanum and molybdenum are used as substrates of semiconductors. So these were elements that were enhanced by hundreds to 1,000 times more than the solar system standard. It could be technological, but the best way to find out is to find a big piece of this object.
Now, those conclusions that we can try to make from that object, how accurate would they be when we try to find out what that area where the object came from is like now? Since I'm assuming it would have traveled for a long, long time, and now things at that place might be very different.
Oh no, so the collision with Earth was less than a decade ago, and there is not much sedimentation in the ocean over a period of 1 decade, so we don't expect much contamination. If indeed the materials we found belong to this meteor, they will not be difficult to recognize. Of course, it could have traveled for billions of years through interstellar space, and it would have gotten bombarded by cosmic rays, and there could have been some material attached to it, but usually it affects only the surface. And this object was at least half a meter in size. We don't know how big it was. Maybe only the outer layer of the object was evaporated in the explosion, and perhaps a big piece in the core of the object survived the impact. So that's what we will try to find, those bigger pieces. There were three flares to the fireball of the explosion, and they may represent the fact that the object broke into three pieces. So we will look for them now that we know where to search. The hope is, if you find such a piece, from the way it looks, you can easily tell if it's natural or artificial.
Hmm. What do you think? How long will that take you and your team to find more pieces and to gather more evidence?
Well, it just takes one additional expedition, and we plan to do it within the coming year. And for now, the challenge for us is to design the equipment, the tools that would allow us to find those bigger pieces, because they would be quite different than the sled, the magnetic sled that we used. And so we are in the process now of designing the tools, and then we will have an estimate for the cost of such an expedition. And hopefully, we will get funded and move
Who
forward with the planning within the coming year.
who funds such projects?
So it's based on donations from people who are inspired by the vision. So in the first expedition, what happened was, after the US Space Command issued the letter to NASA, I started organizing a team of engineers, navigators, people who are the best in the world for ocean expeditions. And at that point, I announced that we need funding at $1.5 million. And within a few months, I had a Zoom call with Charles Hoskinson, who told me that I have the money, that he will be glad to fund it. He came with us actually on the ship and helped us during the expedition. So that was very rewarding. And of course, the next expedition is likely to cost us more. And I hope we will still get what we need.
Okay, that's interesting. Do you not to become too I don't want to get you in a bad light, but why might he fund that? What do you think?
I think he was curious about the question, uh, or the perspective of studying the first object from outside the solar system. because it's a historic event and demonstrating that the materials came from outside the solar system, um, is by itself an important accomplishment in science. There aren't many situations like that, and he realized that he can make a difference by funding it. And there is obviously the possibility that it was artificially produced, which would make it historic even more if we find some piece of technology from another civilization. So he was intrigued, inspired by this.
What would be some second order effects from your finding? If we find out that it is from an alien civilization, would be that would be an awesome finding. What would be second order effects? Like, what can we gather from that? How would should we react? How could we react? Should we react at all?
Right. Well, it really depends on what we find because there is no reason to decide about a protocol ahead of time. If you have a visitor to your backyard, it makes no sense to decide how to respond to that visitor until you know what the visitor is seeking. In the case of a meteor, it's very likely that it was space trash to start with. The way that the Voyager would be once it leaves the solar system, it will not be operational anymore. And it's possible there are many objects like that which are floating in space. They are bound by gravity to the Milky Way galaxy, the way Voyager would be, and they just float in space, and every now and then one of them collides with Earth, and so it appears as a meteor. And then the second type would be objects that are still functional when they arrive to Earth, and they would behave very differently. And I think the best approach is not to imagine what it might be, but instead learn from studying it, because then we could get a glimpse at the future technology that we don't possess at the moment. And our imagination is limited by what we already have. So it's just like dating someone new. You don't want to look at the mirror and imagine that person being the same as you are. You want to be surprised, maybe for the better, because any civilization that reached our doorstep must be more advanced than we are because we didn't reach their doorstep.
I like that metaphor. That's great. Um, did you have any problems with? I'm from Germany. I always in the news here we often hear from findings as such from NASA, for example. Um, and there's always great secrecy about around it, and conspiracy theories start to happen. And did you have any problems with that, with secrecy, or were you allowed? It was your operation, so you were allowed to
No,
share how you
actually,
wanted.
well, no, actually, as I mentioned, the U.S. Space Command, they supported the uh, inference that this is an interstellar object. So they basically took time out of their busy schedule to confirm the discovery of the first interstellar meteor, which is blue sky research. It has nothing to do with national security. So far I got only support from the side of the government. The only pushback that I'm getting is from people who work on space rocks for decades. These are experts, scientists, astronomers who insist that the data from the US government must be wrong, that in fact the speed was 3 times smaller, and this is a stony meteorite. And they actually published a paper on this just as I came back from the expedition with the materials in my hands. Instead of them waiting to see what I find, and instead of them respecting the data from the US Space Command, which, by the way, gets more funding than NASA, and is supposed to tell the US president if a ballistic missile is coming from North Korea. They cannot be fools that they measure things wrong by a factor of three, the way the astronomers were arguing in a published paper as I came back from the expedition. And so finding those materials, first of all, that allows me to sleep better at night because I know that the US Space Command knows what they're talking about. But at the same time, it's an opportunity to learn something new about completely different environments that could produce, this meteor, the unusual properties of the meteor. So I find that as a learning experience where you are not assuming anything about what you might find, and then you let nature tell you, educate you about things you don't know about. In this case, it's what lies outside the solar system, and in the past, astronomers used telescopes to figure this out, and we used microscopes because we studied those small spherules with microscopes. Very different approach, and it's a new frontier for learning about interstellar space. And by the way, I had just a book published a couple of weeks ago, which has a title that is the same as the punchline of the scientific paper that we submitted. Basically, the title is Interstellar, and the book discusses the implications for humanity of finding evidence for another civilization, a partner out there.
Why do experts, or you mentioned, I think, the meteorologists, have such a different view on these findings? How can that be? How can.
Well, it's because they are attached to past knowledge. They got their reputation based on past knowledge. So they insist that anything in the sky must be stones or rocks that are familiar to them. And, that is, I call that the stone age of science, where everything in the sky must be stones. You're not allowing anything new. And the point is, we know now that most of the matter in the universe, 83% of it, is from a substance that we haven't yet witnessed in the solar system. It's called dark matter. And insisting that anything that comes to Earth must be stones is really a very limiting point of view, because then you're not allowing yourself to consider something that is different than the solar system. And I think that the only way to discover new knowledge is to not to be attached to past knowledge, but these people are attached to their own models. In the paper that they wrote just a few months ago, it was said that since their model for stones does not match the US government data, the data must be wrong. And I think that shows arrogance. As scientists, we should be modest, humble, and willing to attend to data that doesn't agree with our models.
Hmm. Um, Let me ask you to dive into a slightly different topic. There have been claims, obviously very popular by Elon Musk, for example, that the human species can be a multi-planet species. What do you think of that? How likely is that, and how likely is that in the near future? I think he said 10 years, and
No, I
it'll
think
be
it
on
will
Mars.
take a while because he ignores the risk on the surface of Mars, for example, the risk from cosmic rays. A human cannot survive for more than a year and a half or so because of the bombardment by cosmic rays that can destroy a significant number, a fraction of the cells in the human brain, in the human body. And the only reason that astronauts spent long periods of times was the protection by the magnetic field of the Earth. If they spent time in space, it was under the Van Allen belts. But if they were to go to the moon or Mars for a period of a year, they would suffer severe health risks. And the only way to avoid that is to go underground into the caves. Those are the lava tubes in Mars. And then, of course, it's just like going back to caves. We started in prehistoric caves, and we might go back to caves on Mars. And I think this problem is not at all solved as to whether we can build the infrastructure in these caves. So I think it will take a while before we have a human basis on the moon or on Mars where humans will stay for years, because you need to protect them. Otherwise, they would die quickly. Uh, and so I don't think we should necessarily move large numbers of people to those environments, it would be easier to use technological gadgets. Um, for example, spacecraft that carry equipment with artificial intelligence. We haven't yet sent AI systems to space, but that I think should be the next step. And then those systems will be far more accomplished than the systems we sent so far to space. The robots we sent, like Perseverance rover or the Ingenuity helicopter, these are on the surface of Mars, but they are managed by engineers in Pasadena in the Jet Propulsion Lab that tell them what to do. I call that helicopter parenting because we are parenting a helicopter on Mars and telling it what to do. And of course, you can't adapt this approach when you go large distances because it takes a long time for even the signals to reach the probe and tell it what to do. So you need probes that are autonomous. Also, the probe cannot transmit a huge amount of data back to Earth. So it needs to be intelligent to make decisions on its own, not to be managed.
Mm.
And that's what AI astronauts that I discuss in my new book, Interstellar, will be. They will be autonomous, they could decide for themselves, and then send a little bit of data back to Earth, just reporting. It's just like a letter, sending a letter home, but not in order to decide what to do in each step, because they will have their own brain. And I think that's much better for us to accomplish tasks sending AI astronauts rather than humans until we solve the health risk issue, which could take a long time, maybe not solvable. You know, as biological creatures, we were created to survive on this planet. We are protected by the atmosphere, the magnetic field, and we are not designed to survive long periods of time in space over more than a couple of years. And therefore, I think we should send technological gadgets. And that's what I imagine that we will have. If we ever witness a functioning device from another civilization, it would be an AI astronaut. So basically, once we discover what others sent in our direction, it will inspire us what technologies to use ourselves.
What do you think of the space race, I would call it, that is currently going on? We don't have just Musk; we also have Bezos and Richard Branson. All are trying to go into space. I'm honest. I don't really understand why. Why is there a current obsession with space and billionaires? Do you know what?
Yeah. So, well, part of it, actually, Jeff Bezos explained it. I was with him in a special panel at the Washington National Cathedral a couple of years ago, and he explained it as that he was inspired as a kid by science fiction like Star Trek, and I never liked science fiction because it violates the laws of physics. But he was inspired to initiate the Blue Origins, and he thinks of space tourism in the future. Um, all of these initiatives have a commercial benefit, and he looks at it from a business perspective. And then you have governments which regard resources or assets in space as useful for either national pride, just demonstrating superiority in technology relative to other nations, or as if they, for example, go just around the Earth, they can use it for intelligence gathering, spying on other nations. And so that is another motivation. Besides commercial, it's national security and national pride. And you see that when China is trying to reach the moon, India is trying to reach the moon, in addition to the US and Europe. So there are these elements, but I think the true reason to go to space is neither of them. It's actually curiosity, exploring the unknown, trying to find life, let's say, in the solar system, or trying to leave the solar system so we can explore even beyond the boundaries of our own planetary system. And that will take, of course, much longer time to reach great distances. But we should start thinking about it. And in fact, I calculated that we are now spending $2 trillion a year on military budgets. And if we decided to live in peace by following John Lennon, imagine all the people living in peace, and then we will have $2 trillion a year as a surplus. And I calculated that would be sufficient to send billions of probes towards every star in the Milky Way galaxy before the end of this century. So it's just a matter of priorities. And
What?
maybe another civilization is more peace seeking and has done that a long time ago. And as a result, we should find some probes in our neighborhood.
But how long would that take for them to come back? We're probably not here
So that
anymore,
takes
right?
about a billion years from the edge of the other side of the Milky Way galaxy. So if you use chemical rockets of the type that we use, the trip between the two ends of the disk of stars in the Milky Way galaxy is about a billion years. But the most stars are billions of years older than the sun. I mean, they existed long before the sun, and we know that. So, if another civilization, started the technological clock more than a billion years before ours, then it had enough time to reach us by now.
And if they tried to do that another civilization, how would we if we were trying to search for a signal, how would we best do that?
Yeah, so in the past, we were looking for radio signals or electromagnetic signals, but that is just like waiting for a phone call. And the approach that I prefer is searching for objects in our backyard or near our mailbox. That's a completely different approach. And we haven't done that until the last decade when the first interstellar objects were found. The first is this meteor that I went after. The second was Oumuamua, an object in 2017 that the size of a football field that appeared to be flat in its shape based on the reflection of sunlight and was also pushed away from the sun by some mysterious force, which I suggested is just the reflection of sunlight from it. And for that, it had to be very thin, and nature doesn't make thin objects. So I suggested maybe it's artificial in origin, maybe a layer, an outer layer of a bigger object that was ripped apart. But at any event, this was the second object, and then there was a third object called Borisov in 2019, which was a comet, just like the familiar comets that we have in the solar system. And so only over the past decade we started finding those objects, and the first two that came from outside the solar system appeared unlike the rocks that we are familiar with, asteroids or comets. And so to me that's intriguing, and means that we need to check each and every object coming in as with as much data as possible so that we can figure out their nature. Because among the rocks, I mean, obviously there would be some rocks like we have in the solar system, but every now and then we might see a tennis ball that was thrown by a neighbor in our backyard.
That's funny. So looking for outer space materials on Earth might be
Yes,
the better option.
on Earth or near Earth. Some of them would pass near Earth, like Oumuamua was. It didn't collide with Earth. But for that, you need the object to be big enough to reflect enough sunlight so that the telescopes that we use will be able to see it. Um, so, altogether, these are called interstellar objects, and it's a new frontier that was never attempted before.
Then I got that wrong. Actually, when I did research for this episode, I thought Oumuamua also was on Earth or parts of it.
No,
It was
no,
not.
no, it came within 1/6 of the Earth-Sun separation, but it didn't collide with Earth. It was the size of a football field, about 100 meters, and it reflected enough sunlight for the survey telescope in Hawaii, Pan-STARRS, to detect it. So there are two ways to detect objects like that. If they collide with Earth, they can be small, half a meter to a meter in size, and they will just produce light as a result of friction with air. They produce an explosion as a result of the fact that at some point they disintegrate. And for example, this first interstellar meteor released a few percent of the Hiroshima atomic bomb energy. So they release a huge amount of energy when they collide with Earth. Uh, but another way to detect such objects is if they pass near Earth, uh, but they reflect enough sunlight. And for that, they need to be big, the size of a football field, for us to notice them. I calculated that there should be millions of meteor sized objects, half a meter in size, within the orbit of the Earth around the Sun at any given time, but we can't see them. Only when they collide with Earth once per decade, we will see them. We will see the fireball from them.
Are there any similarities that you found between these two objects that you examined?
Yeah, so I wanted to check first if there is any relationship between the trajectories that they came
Yeah.
from, and unfortunately, they came from different directions, so they were not related to each other, and also the properties were quite different. So I don't think there was a connection. It's just that you have a lot of objects in interstellar space, and every now and then you either see a big one that comes close to Earth, or you see a small one that collides with Earth. And it could be a mixed bag. There could be objects that are natural, but also some that are not, that are artificial. And we just need to monitor each and every one of them.
How many objects approximately have been found that are interstellar?
Oh, so far only three. It was the meteor that I mentioned, Oumuamua, and the third one was a comet. It's called Borisov, after the Gennady Borisov, the amateur astronomer who discovered it. There is also a second meteor that we identified, uh, and we haven't yet explored in great detail. And that was found in March 2017. So if you want to include that second one, then altogether there are four objects from interstellar space that were found over the past decade.
And any similarities there? Maybe not from the trajectory or from the origin, but anything that is similar?
Well, we hope to eventually visit the site of the second meteor. It's uh, somewhere between Portugal and the Azores, and that will be the target of the third expedition, most likely. But for the second one, we plan to look for bigger pieces of the first meteor because we already studied it. So we have to finish the task of finding
Ah,
out what
okay.
it is. Yeah.
So not yet. There's not yet any evidence or any things that could match.
Well, it's too early at the moment
Yeah.
to decide what the origin was, but the nice thing about science is it's just like a detective story. The more data or clues you collect, the easier it is for you to figure out what it is. So just like a detective, there are twists and turns, and sometimes you have the wrong idea, but then you correct yourself when more data comes in. So that's the plan to look for the bigger pieces to help us figure out the source of this meteor.
Jumping back to the topic we had before, um, what would be conditions for life that need to be so that it can flourish?
Well, we have only one place that we are confident of having life, and that is the Earth. And the one thing that is necessary for sure is liquid water for life as we know it. And the problem with water is if you don't have an external pressure on the water, it goes directly from solid ice into vapor gas
Mm.
phase if you warm it up. So, in order for water to become liquid, you need an external pressure. And in the Earth, it's provided by the atmosphere. So we have oceans, we have rivers, and all of that is thanks to the atmosphere that maintains a pressure. And what happened on Mars, for example, at the middle of its life, about a few billion years ago, it lost the atmosphere, and as a
Mm.
result, it all the water evaporated, and we see those regions on the surface of Mars that were the banks of rivers, and they look like they were shaped by water, liquid water, and that's why we suspect that perhaps there was life on Mars a few billion years ago. And in fact, it could have started on Mars before it started on Earth, because Mars cooled earlier. And it's possible that we are all Martians because Martian rocks, reached Earth, and they could have carried microbes in them. These were the first astronauts, if that happened, that traveled from Mars to Earth. So when Elon Musk wants to go back to Mars, it's just like going back to your childhood home, if Mars had life earlier. And these microbes did it before him, billions of years before him. So nature is much more accomplished than humans. That's the bottom line. But in terms of whether life exists and how far it went on Mars, we don't know yet. My hope is maybe intelligent life, also existed on Mars before it lost its atmosphere. And one thing I want to do is, if we ever visit those caves on Mars, that I want to a drone to enter them and check for any prehistoric paintings. Maybe there was something on Mars before it lost its liquid water. But Mars is basically a warning sign for us as to what would happen on Earth if the atmosphere was lost. And if you ask yourself what's special about Earth relative to Mars, is that surface gravity is larger. On Mars, it's just 42% of the Earth. And because gravity is stronger on Earth, there is magnetic field, Earth was able to keep its atmosphere, and Mars lost it. We don't know exactly why, but it lost it. So uh, that leads astronomers to argue that you need roughly the mass of the Earth or bigger in order to retain an atmosphere, in order to have liquid water. And to have liquid water, you also need to be at the right distance from the star so that the surface of the planet is warmed up such that the solid ice turns into liquid water. So there are two conditions for life as we know it. One is to have a planet the size of the Earth or slightly bigger that retains its atmosphere and does not lose it like Mars did, or any object smaller than Mars would not even have an atmosphere. It would evaporate very quickly. And the second is to be at the right distance from the star, such that the surface will be warmed up and the solid ice will turn into liquid water. And by now we know that a significant fraction of all the stars that look like the sun uh, could have a planet the size of the Earth, roughly at the same separation. And that fraction, the most likely value is around a quarter, but there is a large uncertainty in the fraction, and it could be anywhere between a few percent up to maybe even 100% of all sun-like stars having a planet the size of the Earth, roughly the same separation. So, at any event, it's a substantial fraction, and that leads me to conclude that it's arrogant of us to think that we are unique and special, and it's much more reasonable to imagine many other civilizations that rose and fell and throughout the history, cosmic history, and we just came to exist over the past few million years. That's one part in 10,000 of the age of the universe. And when you arrive late to a play and you are not at the center of stage, and we know now the Earth is not at the center of the universe, uh, then the play is not about you. And
Mm.
in order for you to find what the play is about, you better look for other actors who have been around longer. And that's what I'm trying to do.
Now, when you said that you would look for paintings on Mars to figure out if there might have been a species before there, when you said there might have been life on Mars, I thought maybe one cell organisms, but paintings, that doesn't sound, that sounds more
Well,
developed.
just think about it. It took 4.6 billion years for intelligence to arise on Earth, and Mars, let's say, lost its liquid water 2 billion years ago. That's the one of the latest estimates. So, if Mars was faster in developing intelligent life by a factor of two, so that 2.3 billion years ago there was already intelligent life there instead of 4.6 billion years, that's just a factor of two faster. It's not a huge factor. And we don't know how quickly intelligent life can arise, in a planet like Mars. And if it just happened twice as fast as on Earth, we could find some relics of it there, because there was liquid water, there was an atmosphere when you go back more than 2 billion years.
Now there's no liquid water, and if Elon Musk wants to go to Mars and start a civilization there, there would probably need to be water again. And how could we adapt to that? How would we even do that?
Yeah, no, there is some water ice on Mars, and in fact, enough to maintain a group of, a base, a human base there. Water is useful in several ways. One, uh, needed for, of course, humans to drink, and for agriculture to grow things there. But another, which is perhaps more important, is you can use it as fuel, because you can use the light from the sun to generate an electric current using photocells, and then from that break up. It's called electrolysis. Break up the water molecule into oxygen and hydrogen, and both oxygen and hydrogen are fuels. They can be used as fuels. So you might think that the reservoirs of liquid ice, of solid ice and water, could be as valuable on Mars as the reservoirs of oil here on Earth, for the for the local industries, for propulsion of spacecraft. And I'm sure that will affect the economy. Whoever gets a hold of those reservoirs and develops the the factories that produce oxygen and hydrogen out of the water using photoelectric cells, might make a lot of money out there. Um, there is also, if ever humans establish a sustainable base on either the moon or Mars. By the way, the moon also has solid ice, water ice, and that can be used for the same purpose. Um, there will be a question also how to organize those societies and what kind of a set of rules to establish. It will be an opportunity to start from scratch, not following the tumultuous history of, let's say, Europe, that went through a lot of revolutions until we arrived at democracy as the favorable um, uh, way of governing group of people. There might be an opportunity to make it even better in terms of a new set of laws and a new organization of that. So I think, in principle, going to space allows you to start fresh, perhaps with a better system than we have here on Earth, which in many ways was shaped by unfortunate circumstances throughout history.
I want to now go over to another segment, rapid fire questions. So I will
Sure.
ask you questions, and I would be thankful if you could try to answer them in around about 1 to 2 sentences.
Okay.
Um, okay, let me begin. What does a day in your life look like?
I wake up at around 4 a.m. and then I jog at sunrise after checking my email. And then when I come back, I mean, it's about 3 miles or 5 kilometers every day for half an hour that I run. And I did it also on the ship on the Pacific Ocean. I actually found that I'm running slower over there because I use a workout app and it showed me a slower speed. But then I realized it actually measured the speed of the ship because of the GPS system. So then I realized that I'm running actually at the same pace. So that's what I do early in the morning, then have breakfast. And usually there are lots of interviews every day, plus the scientific work that I'm doing. So it basically fills my day back to back. When I came from the expedition, there were about 10 interviews every day. And that was very exhausting.
What is your favorite space movie and why?
Its arrival because it addresses the question of linguistics, how to communicate with aliens, which I find the most fascinating. And perhaps we'll have to use, I mean, in the film, they use a woman which has a better communication skill than men to communicate with those aliens. But I think that we might use AI to help us.
What is the most realistic space movie you think?
Um, that and The Martian, although there were some in The Martian, there were some aspects that were not scientifically accurate. Like it started with a sandstorm, and you don't expect any storm of that magnitude on Mars because it doesn't have a very dense atmosphere.
Do you have a favorite quote?
Yeah, from Oscar Wilde, we are all in the gutter, but some of us are looking at the stars.
Do you have a favorite joke?
Um, Well, you can think of it as humor. That's what Arthur Schopenhauer, the philosopher, said. He said that all truths go through three stages. At first, they are ridiculed, then they are opposed to very strongly, and the third step is that they are accepted as self evident.
Hmm, I like that. Um, a controversial opinion. I believe what nobody does.
Well, that we might have been visited by some technological gadgets. And of course, I'm trying to get more evidence to support it.
If you had a giant poster, and on, let's say, on Times Square, and you could write anything on it, what would your message be? What would you put on it?
Well, first of all, I have that. I was contacted by the company that owns the big sign in Times Square. It's a board, the electronic board, the biggest one, and they asked me what to put on it, and I put the Galileo project and the expedition. It's a 15-second segment that keeps playing there right now.
Well, that is quite embarrassing for me, but super cool. That's the best answer probably I could have given. What would you have liked to know earlier when you started, or with 20, let's say?
Sorry, say it again.
What would you have liked to know earlier, let's say
Ah,
with 20?
um, Yeah, I would have liked to know that it's more important to follow your passion than to try and get as many likes as possible from other people. Which is, as a young person, I always wanted to be liked, and later in life, I realized that that's misleading because, in fact, we have a limited time, and we better not waste it on trying to make other people happy, but instead do the right thing.
How would you spend $100 billion to make the world a better place?
Oh, um, I would. invest at least $10 billion in searching for um, technological gadgets in the vicinity of Earth. That's roughly the amount that was invested in the Large Hadron Collider at CERN or in the Webb telescope. So, it was spent already on science. And I think this is the question that the public cares about the most. And we should spend a similar amount of money on this question. Are we alone? Do we have a neighbor? And then the remaining 90 billion I would use to avoid as much as possible any existential risks. So that
Mm.
includes making sure that AI technologies are safe for society. Building up systems that defend us from the harms that can be inflicted on society by AI systems, protecting us from nuclear war, making sure that the climate will not deteriorate. All of these tasks, um, that could potentially limit the longevity of humanity. That will be my next step. But the reason that looking for a partner or a neighbor is my first priority is because it will be a wake up call for humanity to try and to realize that there is a smarter classmate in the class of intelligent civilization. And maybe we can be inspired by recognizing that we are not alone, by having a partner, which would change our life, just like finding a partner in real life. It will change the meaning of our existence in the universe.
One second. What's the biggest problem in your area currently?
Well, there are several. First of all, what happened before the Big Bang? That's a big question that we don't have an answer to. Um, so that's our cosmic roots, in a way. What happens inside a black hole? We don't know what happens at the singularity. In both cases, it's because we don't have a quantum theory of gravity. So because Einstein's theory breaks down in the middle of a black hole and also at the Big Bang, the early universe. And then the third thing is, what is most of the matter in the universe? We don't know. It's dark matter. And what's the nature of the energy of the vacuum? We call it the cosmological constant or dark energy. We don't know that either. And are we alone? That will be obviously another question. So all of these are the biggest I can think of.
What do you think is the meaning of life?
I think we get a meaning by having a partner that echoes, the misery of our existence or helps us cope with it. We realize that we have someone to share our experience with. So that's true in our private life, but it's also true in the universe because Steven Weinberg, the Nobel laureate, towards the end of his book, The First 3 Minutes, he said that the more we study the universe, the more pointless it appears to us. And I believe that he said that because he studied objects that are lifeless, like elementary particles, like radiation, that have no life in them.
Mm.
I think the meaning or the universe will not appear to be pointless once we find a partner out there, a cosmic partner, because then, first of all, we could learn from it, but also it will give us a sense that we are not alone and the universe is not pointless anymore because we can develop some relationship. And maybe, the question that I would ask if in such an encounter would be, first of all, what happened before the Big Bang? All these, the questions we discussed before. But second, where is the nearest party where intelligent civilizations meet? And it would be fun to join them.
That I like. Um, what do you think of Neil deGrasse Tyson?
Well, I think he's a very good public speaker, but he presents himself as an astrophysicist, and he hasn't really written a single scientific paper over the past decade or two. And you can be a commentator the way that we see in sports, where someone that used to play makes comments, but that does not give you the privilege of telling the players on the soccer field how to pass the ball,
Hmm.
because you're not playing. I mean, you can express your opinion. So him presenting himself as an astrophysicist when he's not practicing astrophysics, I think, is misleading. And I do think that you have to practice what you preach for in order for what you say to be relevant. And that's what I'm doing. I'm a practicing scientist. I'm still writing scientific papers, but I'm also communicating with the public. And there are very few practitioners that communicate with the public in the context of science. I think it's very important to pay attention to those who actually practice what they preach for.
You've been a guest on Joe Rogan and on Lex Friedman. What do you think, or why do you think they are each so successful?
Well, they have, well, first of all, they are honestly curious about a lot of people, and they unravel interesting personalities that they speak with. And they're very professional, they're dedicated, they keep finding interesting people and asking them good questions. Uh, but they're very different from each other. Lex Friedman is more about technology, Joe Rogan is more about um, what the common person might think about political or scientific events. And I had by now maybe 3,500 interviews over the past 2.5 years, and I had been interviewed on many podcasts. And Obviously, both Joe Rogan and Lex Friedman are very positive when they interview people, and also quite wise in asking the relevant questions and getting new answers out of those people. That's probably what makes them unique in some sense. But I've been also interviewed by many others that are very interesting podcasters, including, for example, last month with Patrick Bet David.
Mm.
And So I enjoyed most of those. And very often, young people ask me even more exciting questions because they're more open minded, they're less trapped in what's already discussed out there.
The last question would be: what is your newest, greatest insight?
Well, it's this extrasolar composition of the material we collected from the first interstellar meteor. So, to me, that's an insight that will tell us something about an environment very different than the solar system. And, with more data, we could get to the bottom of it. So, I'm very excited about it. But every month I have a new paper that for me is a new revelation, something new that I didn't think about. And you can just follow my research by either going to my essays on medium.com. These are more popular level, or looking at my preprints on the archive, just seeing what I have been working on recently.
Or if you want to know more about the general topic at his book, Interstellar. Thank you, AV. Is there anything I should have asked you that I didn't?
No, I just wanted to emphasize that the simple way to think of me is like a curious boy that grew up on a farm, and all the titles that I acquired over the years are not really important. People who know me will tell you that I haven't changed much.
That's
So
very
stay
humble.
young. That's my advice. Stay young in your spirit.
Well, thank you very much, and have a great day.
You too. Bye bye.